Cool. All right. Hey, everyone. I'm here with Abad today, and he's going to be teaching me some computer science, and super excited about that. Yo, tell me a little bit about yourself.
All right. Thank you, James. Thank you for inviting me. So my name is Abad. I'm based out of Boston, and I have a computer science background. That's why I went to college for. But after graduation, I decided to go into teaching and writing. It was because of just one quote. I was listening to a presentation in school during school, and there was this research scientist. His name is Leslie Lamport. He works at Microsoft, and he said, "Writing is nature's way of telling how sloppy your thinking is." Um, and I didn't make anything of that, but it was at the back of my mind. So I was in my networks class, and we were designing an FTP server, and I didn't know where to start, so I just started writing about it. So I wrote about all the states and all those few things, and after 4 hours, I had an idea, and then I realized, oh, maybe writing will help me understand more about computer science. So that's where the seed started, and then it kind of became a blog. Now I do curriculums and couple that with teaching, because I think
Mhm.
if you can write and then kind of um, hold it to scrutiny of other people, I think
Yeah.
it's just a virtuous cycle. I'll be sharing my blog here, which is about data structures and algorithms. It started with doing like blind 75 and putting solutions on LeetCode, their discuss
Yeah.
section. Yeah.
That's so cool. So you
So
started writing while you were studying in college.
yes. So I started posting on discussion boards, and yeah, it was because, as the job market requires you to learn LeetCode, um, it was kind of uh, my way of giving more bandwidth about these questions through writing. And yeah, so the product of that after like a year is the blog Constant Time. I'd like to go more into depth with your permission, of course.
Yeah, for sure. Yeah, I was just gonna say, you know what they say, when Facebook or Twitter is down, they solve it by getting their seven best engineers in a room and solving leak code problems together, right?
Oh, of course. No, that's the two there. One of them is reversing a binary search tree, and the other is a linked list, and that's how the problems are solved. Um, well, yeah. Okay. The seven best engineers write about those problems and put them on blog posts. That's why they're able to
Yeah,
reverse them
cool.
in like constant time.
And your blog
Okay.
is yeah. Um,
Yeah.
your blog is so cool. Have you seen have you gotten a lot of reactions to it?
Yes, yes. I was very surprised. Like I just put it out there.
Yeah.
I started with just writing about it. Like I spent like 6 months making these two roadmaps. And I actually it was live for like about 9 months, and I never published it.
Uh-huh.
And then one day I went on Reddit, and I was like, here is something I made. And I
Yeah.
got like I think 15,000 views and like a really high upvote count. And then people started adding me on LinkedIn, sending me emails. I put my personal email there, and it started getting hacked as well.
No
So
way.
maybe not put your personal email there. So I changed that. But yeah, it was very interesting because in one day I got like I think about 15,000 views, and then I put it on LeetCode, and there it was even more on their discuss section. So then I just put like a newsletter link, and then I started getting those newsletter subscription. I put it a little late, but it's a humble 50 people doing on the newsletter. But I think it's increasing. Yeah, so I am new to Stream,
How do people
so I just present.
yeah, how do people sign up for the newsletter? They just go to constanttime.io and then they'll
Yes, and
I'll just
there's a newsletter. I'll show
yeah,
all this.
cool.
So I'm gonna present. So I can do screen share, right?
Yep.
Okay, screen share. There we go. Constant time. Okay. So this is the blog. It's very simple. If you'd like to know about the stack and like how I'm like what the thing is, it's not very uh, crazy. I can go into detail about it.
Yeah.
But here is where you sign up. It uses Mailchimp on the back end. But yeah, a little bit about this. It might seem a little humble from here. It's just binary search, heaps, and recursion.
Can you text
Go
just a
ahead.
little bit bigger?
Oh, should I make it a little bit bigger?
A little bigger.
Better?
Yeah, that's cool. Perfect.
Okay. So we have binary search and heaps. So you go here. All of these is an article in itself. So they average about 3,000 words and maybe like 5 to 10 illustrations each. I'll go over each of them step by step and kind of talk about all of the components because they're based around components, individual articles, and the whole roadmap. So the roadmap basically builds on top of each other. So if you look at like, let's go to the same thing, you can see that there's like a lot of prerequisites.
Got it.
Yeah, and you can kind of go around and kind of see what a monotonic function is and things like that. So it starts with binary search, which is it's an algorithm in computer science, which basically it's a way for searching. Searching is a very common thing in computers because you put information there and then you have to retrieve it. So the best way to retrieve it can affect a lot of people's life because you don't want to be like this guy, you don't want to be searching in linear time. Yeah, I love The Weeknd, by the way. But yeah, and then you can see that it's like starts with illustrations, and then we go into like a lot of questions that come up. Like why do you choose like the half? Why not 1/3? And then we talk a little bit about that, like why should the location be half? So binary search is basically cutting the search space into half, like something like you would do in a dictionary where things are ordered. And then if you're looking for, let's say, E, and you end up in like, let's say G, it's going to be to the left side. So G, E, like after G, everything can
Does
go away. Similar, you can do that with numbers as well. You had a question, James?
Does that only work when the array is sorted?
That's a very interesting question. We can move to our thought experiment, which actually proves that the array does not have to be sorted. This is a very interesting thing which I came across, which is very interesting. So we go into like the philosophical nature of algorithms as well. So this is like a deeper dive into binary search from vanilla, and then we go into the vanilla to chocolate. Chocolate is basically like a internal naming. So if you like to discover this more, we can go into it. But so thought experiment, basically, binary search can work on an array like this as well. So we talk about, we solved it in linear time, not linear time, but in logarithmic time. But yeah, so it doesn't matter if the array is sorted or not. It matters what you're looking for and how each of these halves play a role. So you can see all of these are greater than 4. So if you end up on this half, no matter what the number is, it's greater than 4. So you have to go to the left side. And same thing here, you have to go to the right side. But the array does not have to be sorted at all. I think we go into depth into this one, which you can see in detail. We talk about, we kind of make halves, and then we can basically see which way to go accordingly. So yeah, so to answer your question, it does not have to be sorted.
Can you walk me through an example of that algorithm, like on the picture that you just showed?
Sure. Okay.
Or just like walk through the algorithm?
The binary search algorithm?
Yeah, that would be really helpful.
Okay. So first, I'm gonna go with like a visual thing. Okay. So let's say you have an array 1, 2, 3, 4, 5, 6, currently sorted, and you're looking for 4. Right. Simple enough. If you were to do it like the very brute force way, you would first check the first number, the second number, the third number, the fourth number.
Yeah.
And you might ask why exactly. I also have one, which is like, does a computer have eyes? And it's like, why can't a computer know that 7 is right over there, right?
Right.
Why does it have to go first, second, third. We talk a little bit about it's like closed door, so it has to open each one of them because CPU has like these tiny eyes called registers, and yet it has to load the data from memory into CPU to know if that number exists there. So that's I go on a little bit of a rant here,
Yeah.
but yeah, but I think it's an important question that kids ask me a lot sometimes.
No, I love that
So
way of I love that way of thinking about it. It reminds me of sort of like Alan Turing with the tape, the tape that gets slid by one spot at a time.
okay,
Or it's sort of
okay.
like how they describe it sometimes as a computer as being like something that reads a tape
Oh yeah.
slid
Oh
through.
yeah, tape. Yeah. So it reads one thing at a time.
Yeah, and you can
Uh,
just flip the tape left or right. Yeah.
yes. Yeah.
Yeah.
And that's how loops work. It just goes back to the starting of the tape where it started from, and then you can keep
Yeah.
looping as well. Very interesting. Like if you look at the internals, I would recommend if someone is interested, like assembly language. It's a good one. But yeah, so basically you end up, this is what we're finding. Like we don't have any idea that it exists there. So we make a random guess and then we end up at 3. So same thing with the dictionary example. So we know that if the array is sorted, meaning that it is um, sorted and it's increasing from left to right, we know that if we end up on 3, we can disregard all the numbers to the left, right?
Right.
Including the one we're on. Surprisingly, so that would mean that the first thing we check is whether that number is equal to the number we're searching for. And if it's not, that could also be disregarded. Right. So there you go. Disregarded all of those. We'll talk about how to write code because visually and like how we talk in English, it's very different than how we write code because
Yeah.
to tell a computer it doesn't have like, it can only see one thing. So you can't your assumption will be like, oh, I'll tell it like it's find me for. So, but you have to like kind of go and explain it to like something like you would to someone who does not know anything about how humans think. So yeah,
Yeah.
so imagine if we end up on a side which is 5, right? So we know we can disregard all the things to the right.
Yeah.
Um, and we can keep repeating the process until we've shortened the range. So if we kind of have a dictionary, like as I said, like a book, if it's sorted, if you end up on G and you're looking for E, you can disregard everything from G to Z. So that's how you can just get rid of a lot of search space. Okay. So I was choosing midpoints randomly, but the way you should do it is basically always go to the half. So James, why do you think we should go to the half? Like, why do you think that's important?
Well, if we go towards the end,
Mhm.
and we're very lucky, maybe we're close to it, and maybe it's actually
Mhm.
in that last few pages. But if
Mhm.
we're unlucky, then it's gonna be towards the beginning, and we chose a spot at the end. Now we have to go back and
Mhm.
check this huge chunk.
Yeah. Exactly. I think it's relying on luck, which can work sometimes. I also try to address this question later on. Like maybe the like data is not like
Mhm.
divided equally. Maybe then we can use a little bit of that. But if we want to be probabilistically have the same answer, it needs to be 1/2. So I give an example where like let's say the answer there's 2 billion numbers and the answer is at the 1 billionth position and we guess the 10th number in the sequence, meaning we go to the very start. We only get rid of 10 numbers.
Yeah,
If we had chosen the middle, we could have gotten rid of a billion numbers, right?
right.
If assuming the array is sorted.
Yeah.
Um, yeah. So then we talk a little bit about the implementation. We set 2 pointers, one to the left and one to the right. That kind of basically tells us that's the range of where the number can exist. The number can exist between left and right. and we basically calculate the middle index between the left and right. Because as we said, this is the range. We choose something in the middle. And we choose 3. And you might be like, why don't we choose 4? Basically, that's arbitrary. There's this thing rounding down and rounding up.
Yeah.
All of the numbers will be accounted for if we round up or if we round down. But common practice is rounding down.
Okay.
Yeah, and then we go and select, get rid of the numbers, like as we did with 3, and then we move the left pointer. So we move the left pointer from here to here now because we knew that this area, the number does not exist. And then we have a shorter range, and then we can keep going. This is only 6 numbers, but it can quickly break down things very, very quickly if you're looking for the number. I would recommend there's this video by this professor called David Malin. He teaches CS50, which is like one of the most taken CS courses, and he takes like a address book and he tears it in half, and then he throws the other half away. And I think it's just what the array is doing, but that kind of speaks to us humans a little bit more. So he throws that away, and you get rid of the whole side. And that basically keeps getting done until you find the number or the left and right pointers overlap, meaning that you ran out of the range. We talk a little bit about integer overflow because, as you know, or like, memory is finite, right? Like it has to be stored on like a memory physically.
Mm-hmm.
So there is only a set amount of storage you can have. Well, that does not describe the thing that I'm trying to describe. What certain languages do is like they represent that how large an integer can be.
Yeah.
Or a decimal as well sometimes. Yeah. And it's normally 32 bits or 64 bits. You can also go to 128 bits, but it's definitely limited. So yeah, so sometimes if you are doing Java or C# or C++, you have to, if you do something like this, when you do left plus right, it might overflow. Because let's say if you can only store 2 billion, this is 1 billion and this is 3 billion, how are you going to store that intermediate value? So yeah, you basically do something like this, which mathematically comes down to canceling out. I did this a while back, but yeah, so it's like it cancels things out. You do it in a different way.
Sort of different steps to get there.
Yeah, definitely. Yeah. So yeah, this is what they sometimes ask, which is like superficially it looks very simple, but if you go into the depth of it, it can speak volumes of how well you understand computers and how different languages represent integers differently, like 32 bits, 64 bits, 128 bits. You can do that. So normally I think it's 32 bits for an integer in most languages, but Python does it differently, so it doesn't have to worry about that. Okay. So yeah, so a little bit. Do you have any questions, James, before we go further?
No, this is really cool. I'm fascinated.
Right. And okay, yeah, I think this is the same example. We talk a little bit about code here, where we check whether. So yeah, this is like basically the code description of what we talked about, converting it into code. I can go into different conditions, like why we use else if versus if. But yeah, so we check whether I can come here. To the very okay. So we keep repeating. Okay. So we keep repeating until the left is so until the right is greater than or equal to left. So while this is true, we keep repeating, meaning that they've not overlapped, because right is to the right side, so it will be at a higher index. Since we're assuming that it's 0 based index for a list, because list is index based right here, as you can see. So if it's a 5, another clarification, so left and right does not mean the number we're on, right? It's the index at that point. So index is the one at the bottom.
Right.
Okay. And then while the range is not overlapped, you can add the binary search code here. And then if you don't find it, you can just return -1. That was the requirement for the lead code question, but you can also return something as a print statement or something else. Okay. So we start by initializing the 2 pointers. Left is 0, and the right one is len nums -1. So in Python, you can get the length of the list, and then you do -1 because length gives you the size. And since you know that arrays, do you know arrays start at index 0?
Yeah.
Okay. So arrays start at index 0, so that's why we have to -1. And then we keep doing this. We calculate the mid here. As you can see, we applied the overflow formula, and then we calculate a guess. If the target is found, we return immediately. So when return happens, the while loop breaks. Like, you don't have to care about the while loop running. If you do return, it just returns. Basically, the function returns. And if that is not true, it looks for another condition, whether it's greater than, if the target is greater than the guess, then we basically move the left pointer. So that will be the example right here. Remove the left pointer over here.
Okay. One question about that first line where you had where you actually set the pointers at the beginning. So if there's let's say there's 3 items in the list that you want to search, that means that left is going to be 0 and right is going to be 2.
Yeah.
Okay, interesting. Because
why do you think it's interesting?
My intuition is that it would be 0 and then 3. You know?
Okay, that's interesting.
Yeah.
So if it's like this, right? If it's like 1, 2, so let's go to the very start. So if you have 1, 2, 3, like let's say, imagine this is the list. I'm putting my hand on the screen, but I know it's like not screen sharing. But yeah, so let's say, is this the list? It's 1, 2, 3.
Yeah.
So yes, the numbers we're searching are 3, 1, 2, 3. But the indexes, we start from 0, and we end, like, the left one will be at 0 and the right one would be at 2.
Yeah.
It might not intuitively seem like we're searching for 3, but if you count from 0, 1, 2, that's 3.
Okay, yeah. So left is the leftmost item within your range, and right is the rightmost item index within the range.
Index, yes. Not item in this case. But yeah, so keep doing that. And we basically move the right pointer to the left, which is the description. Where did it go? I think it's a little below here. Yeah, right here. And then the opposite will be the other case. And if so, the while loop will keep running, and none of these situations will return anything, because this just returns. If this does not return, then the while loop is going to end. So as you know, code runs from top to bottom. So this is this is that tape just going back and forth. And when it's done, it would run to the next part of the tape, and then it would say return 1 if that's not found. So Jim, if you want to kind of go over things more line by line, I would recommend this tool. It's the most amazing tool I've seen, and every time, so it's this thing called Python Tutor. It was developed at Harvard, and the you can comment things out. I would recommend just go edit the code, and then you can comment things out. But what it does, it's going to show you step by step. I'm going to just decrease the size a little bit, just so we can see all of it. So I just start here, and it has this red arrow. So you basically go to this, and then you initialize the array, and you can see this is the array, right? So -1, 0, 3, 5, 9, 12, right? You can comment these ones out because we make a point that if they're negative, they also work. So yeah, so you search, you start with the target is 9. That's what you gave the value as target 9. And then you say left is 0 and right is 5. And then we're going to choose a mid. And what is mid? Mid is 2, right? Because 0 and 5 divided by 2, 2.5, I believe. And then, yeah, so we're rounding down. And then the guess is 3. And then we can basically see a little bit more that guess is guess equal to target. No. And then we're going to see that. So currently we're at mid, so we're going to get rid of all the things on the right side because mid is 2 in this case, and the target was 9. So we know that it's not going to be here. It's going to be to the right side. So what do? We will go to, so we'll move the pointer towards the right. So, and you can see that it's going to go to this condition, and it's going to move the left pointer there. And now it's left is 3 and right is 5 where it was. And then it will keep going, and and then it will return 4, which happens to be the index in this case. So it doesn't return the number because we already knew the number. It returns the index. So this is the whole experience you will get if you go to the blog. It's very, very detailed. It has this moments where there's a bunch of memes in there as well. So there's a few memes I'll be happy to show around. And yeah, so this is the Python tutor. I also use a few other open source projects, such as Visual Algo, which is developed by NUS. This is this university in Singapore. It does a really amazing job. I'll love to show some illustration if someone's interested.
Python tutor is mainly useful for walking through an algorithm step by step and seeing the state, the state of all the variables at any given step.
That's true. Yeah. So yeah, similar to a debugger, but it's more visual as well. So you can kind of see the lists. It works well with lists, dictionaries, and all the basic data structures. It can work with trees as well, but you have to do a little bit of reorganization. I think in the heaps example, which is another, we can see a little bit more in that regard. Another thing is there's follow-ups as well, and there's this understanding the time complexity as well. Like, why is it log n? And talk a little bit about that. And then there's always resources, always references, so you can go on your own to explore a little bit. And then the follow-ups is just asking questions, right? So you might a human tendency is to understand things and then kind of think that it knows all of it. But so it's will the binary search if the order is reversed? Will the binary search if there are negative numbers? Will binary search work if the duplicates values in the array? And then we address the same question, and does it work with recursion? And then it has the example for the recursion as well. This was just binary search. Do you have any questions in terms of the experience? You can go over. Go ahead.
Complexity. What did the time complexity ended up being? Log n? Was that it?
Log n, yeah.
Log n. Interesting. Yeah, I'm a little bit curious now what it would end up being. Maybe that's an exercise for me to do. What it would end up being if we didn't choose the midpoint.
Yeah, that's an interesting question. Because time complexities are basically input agnostic.
Right.
So you can't basically have a time complexity where n is basically the number of inputs. Yeah. You can't have a time complexity that's for the same algorithm be different for both ends. And this is normally for the worst case.
Right. So I had gone to your example where you choose the midpoint at 90% to start your first guess at 90%. That would increase the time complexity, right?
Could you repeat that again? Like if you do, like if you put it to a little bit to the right or left?
Yeah, because you said you should always choose your midpoint in the middle, right?
Mm-hmm.
So if you which is like the optimal way to search, to do a binary search, is to always cut in half directly, right?
Yep. Yep.
So I was curious, like, oh, let's say we would put it at 80% instead of at 50%. That would increase the time complexity, right?
It will increase the time complexity, yes.
Yeah.
But in certain cases, just to be sure, in certain cases, it will be better than log n, meaning if the input is actually towards the right side, meaning towards more of the higher end. But time complexities are interesting because you can take this value to infinity and it will still work. So yeah, so it will increase the time complexity in that case.
You can take the value to infinity and it will still work. Okay. So I can imagine how long it would take to search through an infinitely long list. That's what you're saying?
Mathematically, that will not make like things won't add, but
Yeah,
basically what I mean to say is like n could be as large as possible.
right. You can see what it approaches as the list becomes
Yes, yes,
long.
yes.
How
And
fast it
yeah. And then we have this thing called Desmos, which is a calculator, and then in one of them we kind of do that. Um, um, we kind of see that it just basically tapers off. It just keeps going at a certain, because I think log is like this.
Mhm.
Yeah. So yeah, do an exercise. Like think about time complexity, how it will change.
That's super cool.
Um, yeah. So is it okay if I talk a little bit more about the blog, or would you like to know anything more about any of these?
Oh, yeah, no, go ahead. I'd love to hear more about the blog.
Oh. So basically what we've done with the binary search, it's building things on top of each other. I think people that do lead code, that's like another friend of mine gave this beautiful example. And he says like things that come on this website called Lead Code for interview practice is necessarily not the best questions to learn about the questions that come on Lead Code. So because it's basically what Lead Code is, it filters all the questions that are asked in the interview process. So if you're taking a calc exam, normally you would not study by just learning about calc. Like your understanding will be very, very superficial. So you start with addition first, and maybe like adding things and how to divide stuff.
Yeah.
So uh, that's why I think it's important to build things step by step and talk about things like, oh, how does a computer process information? How is the how are elements stored in a list? So index 0, index 1, things like that. So it builds from the very basic, and then it kind of takes things and adds them together. As you say, binary search vanilla, then chocolate, and then it asks these. There's a lot of these philosophical questions that we ask, and always give dedications. Yeah, and then it kind of keeps building on different patterns as well. So I think patterns. So I think road mapping, which is basically building things on top of each other. So at a time when you go to the very end, like remember we talked about the thought experiment. Does the array have to be sorted? And then
Yeah.
we give a few examples of these questions, which we will solve where the array is not sorted. So one of them is peak mountain array. So you see the array is not sorted.
Right.
But if you end up on either half, you can see it's like this. Yeah. So there are these two halves that come. So it's the increasing half. So if you're kind of in the increasing half, you know that the peak is to the right side, and if
Uh-huh.
you're on the decreasing half, the peak is going to be to the left side, right?
Oh.
This is the peak. So it becomes very like it's a very complicated question if you look at on LeetCode and people are like, oh, how do you solve this? But if you look at this question, like the thought experiment we did, where it's the same thing. Imagine these are a little greater. In the peak case, it's like it's both of them are less than. But it's a story about halves. But the point is, it connects those things together, and you can see these prerequisites helping you out across the way, and also more resources as well. So yeah, so same thing here, like prerequisites. Like you need to know about monotonic functions in order to solve this problem. And yeah, we go into detail, illustrations. I think visual illustrations help a lot
Yeah.
to kind of talk about binary search, because to a computer, these are all the same size, but to us, we kind of view things visually. So 27 is bigger, right? And yeah, things like that. And then another thing that I think is very important in LeetCode is I initially talked about these patterns, and questions build on top of different questions. So you basically, we solve this, find the first true in sorted Boolean array. And the code for this question is pretty much the same. We're just adding this function. So instead of returning true or false from the array, we're returning true or false from a question. I'll recommend anyone who's interested in this and go into this and kind of look into this. But the code is basically the same. We're just adding an input from a function instead of getting it directly from an array that we had.
Okay.
Yeah. To the point again, similar questions. You'll see that what is the common thread, minimum number of days, maximum possible positive integer, and greater than or equal to the element, maximum number of minutes. So it's all talking about the upper range, so upper or lower range. And we talk about that over here and how it could be converted into binary search. And these are dedications if you want to study them a little bit further. So yeah, this is binary search. I think it has like around 60,000 words and maybe a couple hundred illustrations.
Wow.
And
you wrote all of that before sharing it with people.
yeah. So I just kept on writing, and I kept on writing, and I kept on writing, and I didn't share. But then I shared it on Reddit. I can show you the post as well. It got like
peers in college.
Come again?
Did you share it with any of your peers in college?
No. This I started writing as I graduated college, but the initial LeetCode questions, those I wrote. James, is it okay if I open the window? It's getting really hot in here.
Yeah, sure. Go ahead.
Are you in New Hampshire, you said?
Yeah.
Oh, yeah. I'm in Boston, so it got really hot.
You know, I was in Boston yesterday, and I heard that was one of the hottest. That was one of the hottest days in May, you know, that they've had, right?
Yeah, it was really hot. I think it was 30. Oh, yeah. I don't know Fahrenheit, but it was 30 Fahrenheit.
Yeah.
So
and we just had one comment come in the past few minutes. Had some people joining us live, and question was, where do I find the roadmap and doc? Well, that would just be go to constanttime.io. That's it. And what is the interface? I think that probably means like that might be referring to the Python tutor aspect, right?
Okay, yeah. So the interface basically, if that is the question, if not, if I'm incorrect, you can correct me. But yeah, so basically, there's two ways you can access this. One is basically it's embedded. It's embedded as an iframe. Iframes are my favorite. It's like this. You can put like a whole website in your own website. So you can basically do next, and then it will run line by line. You can also go further in time. Okay, that's up to you. Another thing is like maybe you want to see a particular thing happen. So you want to see what value it returns. So I can just go here, and if I go down, and it will show me all the times it returns a value. So I would recommend just playing with it a little bit. But it's very simple to use, and I can go into editing the code. Can you see my screen, or is it just on the constant time? I think. Okay, I think it's still on constant time.
We
So
can see it.
Oh, could you see the Python tutor in another window?
Oh, I can see Python tutor right now going.
Share
Okay.
this tab instead.
Oh, okay.
Okay. So here you can go out and basically comment things out and basically have different inputs. And you can just basically keep going. So the reason I mentioned this part is because this is just a for loop, and it can get really, really tedious if you're just going over the for loop again and again.
Yeah.
So it's better to just kind of see what the value is being returned over here. And so you can see like it was false for which values. Another thing is you can move objects, very interesting, like you can move things like that. It might not make sense over right now, but if you're dealing with heaps and stuff, or like trees, because you can create trees using classes, and then you can just bring them together in a way where they make more sense. Otherwise, there's one like drawback of this. It just does not put things at the right place. But you can of course move them. Also get rid of these things that you don't want, and it will just kind of get rid of those for you, because if it's getting too cluttered, like you can get rid of this part by just typing it in here. And you can also just make the things a little bit more clunky if you like, if you weren't able to find the arrows. But I would recommend this if you're doing lead code. It just helps you see the inputs in how step by step, because intuitively sometimes there's certain patterns or certain questions where if you go step by step, you're able to understand it more intuitively, and that kind of feeds into itself.
Cool. And that's what, like pythontutor.com?
Pythontutor.com.
Cool.
Yeah, I can send the link in the chat if there is a chat. Yeah, there it is. Oh, that's the private chat, right? So I'll do that. One of the things, this is my favorite because it doesn't store code anywhere. And what it does, it basically generates an actual link that has all the code. So if you look at this link, it basically has all the code in it. And it uses a certain type of mapping. I think 20 is space, I believe. Yeah. So yeah, all of the code is in here. So if you look at it just like as text, you'll see the whole code is in the link. So if I send this whole code, you will be able to run it in like real time. But yeah. So that's an interesting.
I think URLs can get up to like 2,000 bytes, so you can fit some programs in there.
Yeah, it's a pain to share over certain places where it's very low. They didn't take it Maryland, but yeah. So I think this is a pretty cool application. There's also one called. I think we'll talk about that if you guys want. But they're all incorporated into the roadmaps, and you can see them more. Would you like me to talk a little bit more about heaps?
Yeah, sure. Let's do it.
Yeah. So I think binary search was my first roadmap. So it was very, very chaotic. Like it didn't kind of like, I just kept on writing, and it was like my first time doing it. So it still came out to be, I drafted it 5 times because I wanted to like flow in a certain way. But heaps was more effortless in a way because you have like these patterns, and then we have this thing called the similar questions, which I think is the most important thing here. Because if you're doing lead code, it doesn't matter if you do 1,500 questions, if you do even 500 questions. There's only like, I think 50 to 60 patterns that you need to know. And all of those questions basically have parent questions, and then they have children questions. So we solve this question like kth largest smallest element in an array. If you can use a heap, and you can see that basically it's a kth superlative. So if that comes anywhere, you know that it's you're going to use a heap. And then we talk a little bit about lowest, highest.
Can you make the text a little bit bigger? The text.
Oh yeah.
Cool.
Yeah.
Nice.
Yeah, and yeah, if you see other questions, you can submit them on a Google form, and then I'll add them here. I want to do it using GitHub, like you can edit on a GitHub and you can submit, but I will. It takes a lot of time to just convert it to a different technology stack. So
Yeah. How did you make this site?
that's a very interesting question. So first, I tried using AWS, and I was considering like static website generators and all that kind of stuff. But I was like,
Sure.
I'm gonna do AWS because. Did you
Yeah.
say something, James?
Oh yeah, I said Astro is one that I tried.
Oh yes, that
Yeah.
is my favorite now because that's what I'm using to build my other projects.
Uh-huh.
And Astro is super simple. Like you can just pass everything as props, and then it kind of makes the web page using a template. So yeah, so Astro will be the next logical step for this. But yeah,
You
a little bit about Heap. Go ahead.
You said you started with AWS, right?
Oh yes, yes. So I started with AWS. So this was me doing hosting for the first time in a way. So I had done some hosting through static website generator, not static website generators. There's this thing called S3.
Yeah.
And you can basically host an S3 bucket and then have like a URL attached to it. So that's what my first step was. And then the problem was that there's so many resources here. Like there's images, there's text, and then there's links going back and forth. It was very hard to maintain some sort of a folder hierarchy. Where do I put the assets? Do I put them in a separate folder or things like that? So I ditched that, and then I found this service called super.so, which basically it's not very technical. So if anyone's looking to make a blog that has not much technical, that maybe is intimidated by a little bit technical thing, it basically takes your Notion page and then converts that to a website. So this
Cool.
it's all using Notion as a database.
How's the SEO with that? Does it get indexed okay by Google?
I made this public like two months ago.
Yeah.
But I haven't not invested much time in SEO. Maybe you can help me there. This was I just posted it, and
yeah,
it's doing so far okay.
I was just asking because I've also seen super.so, and I know that it uses a lot of JavaScript to create the pages from Notion. So I was just curious if they were doing if that was how SEO that is. But yeah, no, I'll check it later. Cool.
Yeah, they provide an SEO, and they say like you can add like the keywords and stuff.
Cool.
But I didn't pay much attention to it because that was not a priority at that time. It's kind of growing organically
That's great.
Yeah. So Heaps is similar, and you can see that I failed to mention like these are recommended ones because this is a very detailed roadmap, and it could take like a month to finish. So some people are on a timeline, so they can kind of look at the things that are most important. And a few features I would recommend. One is the roadmap that I've used, and the other is stories. So this one is like the greedy merchant. No one is wise from another man's woe. And then this is like the guy. He goes to a magician, and he gets like a bag that sorts things, and basically that bag is a heap. And then I think it helps you understand things a little bit more clearly. And then thanks a heap. It has some memes in there. Because same thing here. We talk about, so you might be saying this is just a list, but heap actually is just a list, as we talk about in simulating a max heap.
What is a heap?
So a heap is basically a data structure that that does partial sorting in a way. So what it comes to be is like all the elements to the right side are so all the elements to just give me a minute. Okay, so yeah. So things that are going to be one layer below are going to be less than the one that is on the top. So things that are going to be like, let's say the first level is 90, and the things that are going to be on the second level are going to be less than that 90.
Oh.
And then,
Oh.
yeah. So it's different than I forget what is it, a complete search tree or a binary search tree. Yeah, it's a different than binary search tree.
So it's a tree where every
Mhm.
node in the tree can have 2 children or any number of children.
So that's an interesting question. So it can only have 2 children.
Oh, okay.
And the reason for that is because you use a mapping function to kind of convert the array into a heap.
Yeah.
So an array is basically like this, right? So it's a list, but you're
Yeah.
kind of mapping a function where if you're on the first one,
Yeah.
so where do you think its child is going to be? So which one is the child, right? So if you see 36 and 17 are the children, right?
Yeah.
And for 36 is 25 and 26. So if you look at the list, you can basically see that you can use a formula here. This was a while back, but yeah, so you can multiply things by 2 to get to the parent. Yeah, so to the left child, you can multiply things by 2. So if you go here and you can multiply things by 2 to get the left child, in this case it's 2. You remember 36 was second? And then if you add 1 to it, that becomes the right child. But if you want to go to 36, the difference between 36 here and 25 is also 2. And 17, if you want to go to its child, so you multiply that by 2, and that will be 6. So 17 right here is going to be the 6th index. I believe that's 7 right here. So yeah. So yeah. So it basically talks about how you can map these things using an array. And for this, I use this thing called Visual Algo.
Uh-huh.
And I would recommend anybody to use this because this just basically talks in the context of heaps. But if I go here, I think this is also a very good resource.
Yeah.
You can see that, so you can do sorting here. And there's some things where it talks a little bit about okay. So basically you can do sort, and yeah, I think it's using bubble sort. Yeah, just using bubble sort in this case, and you can see it visually. And then you can see insertion sort, and then you can do sort, and then it's doing insertion sort. And then you can adjust the speed and everything. So I think that's like a interesting visual tool. And so I was able to find a lot of these when I was trying to understand things myself.
Oh, that's
Yeah.
really beautiful.
Yeah, and it's not just sorting. It has like a lot of things. So I think it's good for minimum spanning tree, recursion, and yeah, cycle find. This is such a good resource. I'll leave this in the chat as well, so privately, and you can send that to the people. Yeah. So it's. I think one thing is like, if you're expecting something from the blog, I think it just takes you step by step, really, really in detail. And if you do it once, I think you'll be able to do 95% of the questions that come to regarding heaps. Yeah, and the similar questions are really helpful.
Yeah.
And then illustrations was the fun part that I enjoyed doing, because like this is Twitter, this is designing Twitter, and you use a heap to basically create someone's feed.
Oh, change back to the tab.
Oh yeah, my bad. Okay.
Yeah.
Oh, yeah. So this was design Twitter, which is a way to like k smallest array merge k sorts. This was asked. I was in an interview in Uber, and
Uh-huh.
then they asked me this thing, and this was in 2022, and then the next day I did it. So I think I basically in the end gave like a personal. So it's like I was asked this question and I absolutely messed it up. This tutorial is dedicated to that and the things I learned from it. Because I messed it up. It was and after I did it, it made sense. But at that time,
How did the interview go?
it went very badly. It went because I started lead code at that time.
Yeah.
And he went and he's like, could you do this? And I was able to I was able to connect things from like, oh, how would I do two arrays? So
Yeah.
k arrays is basically like it could be like 5, 6, 7. So
Yeah.
I started with 2, and then I couldn't make the jump from 2 to 3, and 3 to 4, and then onwards. But it didn't go really well. So that's this one is especially dedicated to that part.
Well, I love that
but
you make a good thing out of learning from your mistakes, and maybe there's who knows, maybe there's even someone out there that can thank you for helping them get into Twitter.
Yeah, I'll appreciate that. But no, but the messages have been really helpful. Yeah, I can show them to you, like the way how I uploaded it, because that just basically reaffirmed the idea that, oh, I worked like, I don't know, I spent like 1,000 hours on this.
Yeah.
And I didn't push it out there. And a lot of people also feel the same way sometimes when they're putting things online. I don't know, maybe you can speak to that as well. Like, what was your first time putting things out there, or how was the experience like? But yeah, I did it. Let me see if I can find that. Let's go to the source.
Reddit.
View. Yeah, I think it was Reddit. And I was really surprised. It was like it did really, really well. Yeah. So this one. So yep. Okay. Okay, just give me 1 minute.
Yeah.
Is this sharing?
Mm-hmm.
It's not sharing, right? Okay, just give me 1 minute.
Are those birds outside?
Yes. Okay.
Yes.
So this was I was like the most comprehensive, and I just did it because I was like at 12 a.m. and I was like, why not? And then it got like 14K views, and it was like a really good upvote, and then 161 shares. And the comments were the most interesting thing, and they were like, really needed this, thanks a lot. There was come again.
Zoom in a little.
Huh?
Zoom in. Yeah, perfect. Oh, okay, that's a lot. Perfect. Yeah, good.
Yeah, and then it was just like the comments, everyone was like super helpful, super helpful, super helpful. And then I met a few people from Reddit, and we talked. And yeah, that was the Reddit one. And this was for the LeetCode one. And there are also some people that are just like very rude sometimes.
Oh, really?
Yeah, sometimes. Not on this one, but there were on other things that I posted. So yeah, so let me just go with my LeetCode. So LeetCode, this one was, I think it was this one. Yeah, it got 78 upvotes for only 2.6K. And yeah, the comments here. Oh, I'm not sharing that. Okay. And yeah, it was all positive. It was all positive. So I was really happy that it's helping people out.
Yeah, it is. Cool. And how long ago was this?
This was the LeetCode one was March, and the Reddit one was 2 months ago.
Okay, not so long ago.
Yeah, so not so long ago, but this has been up for a while. And yeah, I think now people are signed up to the mailing list. I would like to post more, um, but I have two other projects I'm working on. One is related to lead code, and the other is like another project around curriculums that I'm building. Yeah, so.
So you spend a lot of your time on education, right? You also teach kids as well.
Yes. So my full time, you could say my full time job, I spend 30 to 40 hours teaching kids at this company called Coding with Kids. And
Wow,
I teach, I
that's
think
a lot of work.
eight. Yes. Yes. Um, I just, I just want to get like as much experience in different languages because they have like a lot of courseworks.
Yeah,
So you can see like I have a robotics kit under my bed. I've taught Minecraft, Lua, Python, Scratch. Minecraft is Java basically, but
hmm
yeah. So I think all of the programming languages that I didn't expect, and then um, yeah, I think I've taught like I don't know maybe 30 types of classes, like 30 courseworks. That's like Python is a separate one, then Java, C Sharp.
that's for
Um,
or no, that's all for kids or different levels.
so so the highest they go is high school kids.
hmm
So like the eldest students I have are 18 and they're in senior year giving APs and they're
Right.
currently getting into university. Um, so yeah, so it's kind of starting from like 5-year-olds. I've taught 5-year-olds. It's a way different experience across the spectrum. Um,
Oh yeah,
yeah, so
that's really
it's
cool. You're teaching so many different levels at the same time.
yeah, yeah. So James, could you tell a little bit about how your experience has been? I would like to know a little bit more about how, if you're comfortable, like how your experience has been in terms of sharing content online and how it started for you.
Yeah. Um, so actually, I mean, my dream was to, also just to educate as many people as possible. But when I started making content, kind of, I feel really um, like I can relate to how you did because in a similar way, I just started by teaching the stuff that I was learning myself. And my YouTube channel started because there was like a couple small things that I needed to figure out, and it took me way longer than it should have. And I said, "Oh, I should just make a video so someone can learn this in 10 minutes instead of 3 hours." Um,
Okay.
and that was a couple of years ago. I don't know. I think at first I put out like 10, 20 videos and sort of watched it grow, which was sort of like a flat line for a while, like a mostly flat line for a while. And then
Mhm.
at some point, a few months in, the algorithm picked up some of my videos, and then I started to um, see really interesting things, see people, starting to discover me. And maybe more than a year later, um, I came back to it, and
Okay.
I decided, okay, now that I have sort of this a little bit of data from my first set of videos, I want to learn. I want to try experiment new things. Um, and then 3 months ago, I started this program, Build Space
Oh yeah.
in San Francisco, and that was a really important moment for me where I realized I realized a few things, but I started that gave me sort of the encouragement to experiment even more and try out like some new things like live streaming that I had
Okay.
ne- that I had never tried before. And one of the reasons to live stream was exactly what you said before. Lots of us we make amazing stuff, and then we are afraid to to share it with the world because we think maybe it's not ready. And I can relate to that. Spending so much time editing videos that maybe I don't even have to. And what I love about live streaming is you have no choice. you cannot
Yeah.
you cannot stop to edit something, and sometimes you think something is
is no good, and then it ends up being people end up joining the stream and loving it, and so that's been a huge learning experience for me.
Oh, yeah. I'm glad it's an evolution. Like it started from somewhere and now it's kind of taking its form, and you're doing it in a more meaningful way, and you're learning across as well, like, and you're sharing that. Could you tell a little bit about your experience with BuildSpace? Like, because I applied for nights and weekends,
Of course.
and
Yeah,
I think I'm gonna be doing it if I get in.
of course.
So yeah, and one of the things that I'm going to be doing for BuildSpace is kind of creating a YouTube playlist on a course around
Sweet.
teaching programming.
Sweet.
So could you tell a little bit about your experience of like how does BuildSpace force you to create content, and like what is the community structure and how that helps you to do that?
Yeah. So BuildSpace Nights and Weekends is this program. I think it's like 10 weeks or something, but basically every single week for the whole period, you have to share what you've done that week publicly.
Okay.
It doesn't matter, as well as reaching out to like a few people and getting like direct feedback from them within BuildSpace, in
Mhm.
small groups. And what that does is it just completes that feedback cycle. And the other thing is that because everyone's sort of in the same position, they're like really supportive of each other. They understand that, oh, what you're doing isn't finished. It's like sort of just like having a small group of friends or a community that is excited to see what you did this week, regardless of if it was a good week for you or a bad week for you.
Mhm.
And at the end, a lot's changing now because they're kind of moving to this new platform called Sage.
Oh
Uh,
yeah.
but yeah, I mean, at the end, there's often just like lots and lots of new projects you get exposed to through it, and hopefully connecting with other people,
Oh yeah.
us, that who can just work
Oh
together.
yeah, I messaged you on Sage, or there's this dashboard where I asked Sage, I was like, who are some people that are into education content? And James is this person from New Hampshire, and then he had 3 pictures, and
Yeah,
then yeah, so
actually,
that's
this is
that's
already it. This is basically already it. But nights and
mhm,
weekends will just be even more of this, and a little
mhm,
more structured.
yeah. So another thank you for sharing on that. Also, I don't want to take it away from the theme of the stream. Is there like a theme I should be talking about, or is it more of like a casual conversation as well?
This is great. I have one question from someone
Mhm,
waiting, but it has to do with binary search.
sure.
Sure. So it's from my friend Teresa, and she says, "Hey, I just joined. I love binary search. Do you have some content on why it performs better on unsorted data than sorted?"
Do you have some content on why it performs better on unsorted data than sorted? That's that's a very that's an interesting question. Like data, I think data could be a very overloaded term here. I think one thing you should look at, I think I'm going to just share my screen again. So I think one of the things that could be considered data is just the mathematical function of why it's log n. Like if you keep um, things, if you keep chopping things, um, there'll come a point where you would reach just one thing, and there's like a mathematical reason for how you can uh, prove that it's better, and you can't do that if it's unsorted. So it's an interesting question because is there data on whether it works better on unsorted versus sorted? Um, First of all, it doesn't work on unsorted. Well, it does work on unsorted, but both of them Um, let me read the question again. Unsorted data, then sorted.
I'm actually
I'm having a brain freeze right now.
I'm actually a little confused myself because you mentioned, it also works on unsorted data,
Mhm.
right? The binaries.
Mhm.
But I'm imagining that if I'm gonna like each step in the binary search, you have to choose which direction you want to go. The you want to choose the
Mhm.
left half or the right half. But so if you're working on unsorted data, how do you prevent that you miss the thing that you're looking for because you choose the wrong side? See what I'm saying?
Okay. So yeah, and I completely understand. I think
Yeah.
that makes more sense. So the thought experiment was the fact that unsortedness, a certain unsortedness will work with binary search. It would not work, yeah, a certain.
Got-
And we talk about a little bit in terms of um, the like what needs to be the case between different halves. So in this case, if you end up on this half, so let's
Yeah.
say we're looking for 4, um, I don't think it could be used very reliably on unsorted data,
Hmm.
because this was just to prove a point that it's not the sortedness that um, counts for it working. There's an underlying principle
Got
of
it.
how, if you end up on either side, how the target or the thing you're looking for is related to that half. So not all unsorted, like if 9 was over here, then
Yeah.
it will not work.
Got it.
Right. Yeah. So yeah, I think that might have answered the question. But if the unsorted data is like this, the one that's on the screen, it will have the same complexity on working with sorted versus unsorted.
I'm definitely gonna go through this thought experiment later. It looks
Yeah.
really
Yeah, I hope that answered the question.
cool.
I think
Yeah. She just said, I think there have to be stricter conditions for the unsorted case. Yeah, which is sort of what you were saying.
I'm also not sure that much. Maybe. I think there have to be a stricter condition for the unsorted case. The interesting thing is, I said that you can't apply the unsortedness principle and binary search in real life. It's just a thought experiment that we did that it's not just sortedness of the array, because there are questions like minimum in a rotated search in a rotated array. So this is a unsorted array, right? Because it's 5, 6, 1, 2, 3, 4. But binary search can still work because it's a question of which half you're on, and you can still reliably make it to the target if you satisfy a certain type of unsortedness. So I wouldn't recommend, like, I don't think anybody uses binary search on unsorted data reliably. The condition it has to be sorted, but there are certain cases like this question I would look at, and also the peak in a mountain array. So this is also unsorted, right? Like it's 1, 2, 3, 4, 3, 2, 1. It's not 4, 5, 6, 7, but you can know that if you're on this area, the peak is going to be to the left side. If you're on the 2 on the left side, the peak is going to be on the right side.
Okay, so here that it's a mountain array.
Yes. So it's you have to make certain guarantees about the data before applying binary search on it. Yeah.
Those look like really fun examples.
Yeah. There's a emoji in there as well. So that's one. But yeah, that was like I think my internal artist was coming, like my internal artist creative side was coming out here.
That's cool.
But yeah, I used Miro for it. I think that's like a very good tool.
Mm-hmm. Awesome. Yeah, well, it's so cool to see this. I hope this is gonna help you know, a lot more people that are learning about algorithms. Um, just tell me a bit more about, you know, what are your hopes for the future, and you're working on all these cool educational projects. How does it all kind of come together for you, and what do you want to do? What do you want to make?
That's a very interesting question. Thank you for asking that.
Yeah.
I actually don't know. Like, it's always easier to connect the dots looking backwards, but when you're going like forward, it's very hard. But I'm sticking
Mm.
to a certain principle where I'm trying to do what I really enjoy, um, and creating educational content and teaching definitely is my calling in a way, which currently that I think right now. But yeah, I had a job getting out of college, but I didn't take that because I wanted to do more teaching.
Yeah.
Um, and currently, I'm working on. I occasionally write blogs
Hmm.
about these concepts of like, does a computer have eyes, or are you smarter than a computer? Things like that. Um, and then I make curriculums for. I'm currently working on Scratch and Python. I currently, yeah, I have a. I'm just going all in on that one. And another thing, I'm partnering up with someone to build an extension, which I think you can help with because you're an LLM person, uh, a little bit. But it's yeah. Would you? I would like to share it and get your opinion on it.
Sure.
So what it uses is like, you could say buzzword AI, but what it uses is like lead code is like, you solve these lead code problems,
Yeah.
and it's not just about solving those lead code problems that's the challenge. It's also remembering them, because if you've done lead code, like after 3 months you completely forget about it. So the problem with that is there's no like tracking of your progress of how you came up with the solution, because you start with like, I remember first time I did this thing called twosome, which is like a very simple problem. It
Hmm.
took me like 2 hours, um, and all of those insights are lost on how I reached to the solution I did. So what it does, it's very simple. It let me just share that. I think, just give me 1 minute. I'm just gonna go to lead code problems. Okay.
So I'm looking up twosome. It says given an array of integer numbers and an integer target, return the indices of the two numbers such that they add up to the target.
Yeah.
Um,
So the actually the question is irrelevant in this case, but
mhm.
like how you go around solving it. So
Right.
what it does is you create, you solve a problem, and you get like a message in the input if the answer is wrong, or you basically have a certain way of solving the problem, right?
Yeah.
So what we do is we take two things. We take your code,
Yeah.
right? Because when you click on lead code, it sends I think it's a post request. It sends a post request,
Yeah.
and that has all your code in it. And then it basically gets a request that has the answer on how you did, basically. So what it does, it combines those two things and creates like a little report for you on where you were at that particular time. So if you made an error, it will log that error, and it will say, first attempt, you had this error, and you were at this part where you were using double loops. And you can fine tune it in a way where you are like, it's giving you input around, oh, I'm trying to optimize for time complexity. I'm trying to optimize for syntax. And if it realizes you missed a semicolon, and it can just point that out.
Mhm.
Maybe later you can parse that data and kind of create exercises for yourself, like, oh, it
Mm.
can give you exercises where you have to fill out those differences in your understanding, but it just gives you a high level version control of how you came up with the solution.
Mm.
Um, And yeah, so the science behind it is in order to activate a memory, you need some sort of activation around that memory, and then it basically connects those neurons. So the goal here is like kind of keep track of all those memories
Yeah.
in a way where if you look at it, all of those neurons fire back, and then you can kind of immediately retrieve the learning process you had after 5 months. So the reason I say that is because I have like I do that and my friends do that, is like whenever they solve a lead code problem, it's basically like it's something like this. So this was the idea behind it. So if I do this, okay, where is it? To some, yeah. So basically, I had first try, duplicate indices, syntax errors, redundant checks. Yeah, and it's basically just kind of having the first try, the second try, and the third try, and it will
Yeah.
basically be pasted in here as analysis. This is not actually my notes. This is just me testing it out. And then you can see like I was making like the extension and testing it out. So it's all runtime errors. And it's just me testing out because I wasn't able to find this at the very end because all of them are just me testing the extension out.
So
Yeah.
this was generated?
No. This is just me just putting an analysis.
Uh-huh.
And basically I'm using analysis as a delimiter. So
Yeah.
when I make the call, I want to separate the analysis and the code.
Yeah.
Because the analysis, you can also use previous tries to kind of get like, oh, previously you did this. Now the new thing that you're adding here is that. So currently the infrastructure is working. Like I'm able to listen to the calls, make a call to the OpenAI API. But the main challenge that we're going to have is like kind of fine tuning it to give us results that the user sets it to. So like if I want to, so there's this thing called time complexity, which is like how much time complexity is. This is n squared. So what it will do is it will basically give a little bit note that, oh, the time complexity was n squared. If you don't select the option of time complexity, it will not focus on that. So it's like it's going to take notes on optimizing a few things. One would be time complexity. I'm not sure, so bear with me a little bit, like how I will structure this.
Sure.
But one will be like maybe like you're looking for time complexity, and then it will basically give you at the end, which LLMs are very good at doing. Like they can add the thing in the very end. And also it could be like maybe compare my last try and this try and compare and create like a 50 word note. Or it could be around how can I make the syntax better, right? So maybe you're making like a call every time to the target. Like in other cases, it might make sense where you're just getting the number every time from the list, but instead you can store it in a particular variable and use that instead of in the loop calling the list every time. So that's just the idea. So currently up till this point, it's working where you can just basically add things like this. But this is not generated. This is you just putting as a delimiter. And this was like at the very end here. Like this was, I think, start of January, I was doing this. But yeah, so this
it's sort of like an AI journal for your learning process while you're solving lead code problems.
Exactly. That's all it is.
That's cool.
It's very simple. So currently what I could use your help on is like I'm trying different models. And I'm trying Mistral, I'm trying CodeLlama. And now you don't have to host your own. Like there's a lot of APIs like Together AI and like
have you tried
Perplexity. What?
Have you tried Claude?
Yes.
Uh-huh.
But I think in order to create that journal of like what was the most important thing, like note the most important thing down, you don't need a very complicated model. Like I think Mistral 7 billion does that a good job. But then I will have to like do a little bit of fine tuning in terms of that. So that's one thing. The other thing is the cost of it, because I'm not sure Like if the 1,000 people use this, or maybe 100 people use this, I'm fine with bearing the cost. But if it scales, if I have to scale, what should be the cost structure like? Because I've seen you've done a few videos on different.
Sure.
Yeah, so a little bit on that.
That sounds cool. Yeah, that's something we can definitely jam on a little bit. I'd be happy to.
By the way, I'm sweating like crazy. It's so hot. Like, what is the temperature? It's
I'm gonna-
25. I don't know what that is. Yeah, so that's
it must be more than 80 degrees right now in Boston.
yeah. And I don't have an AC in my room.
That's okay, that's 77, but it's getting there. Well,
But yeah, you were saying.
cool. It's awesome to hear you have all these ideas about educating people and teaching people how to code.
Yeah. I appreciate that. Thank you for having me on the stream.
Yeah, we'll definitely work together more. And it's a beautiful day in New England, so hope you can enjoy it a little bit.
Yeah, definitely. And if you're in Boston, let me know. Maybe we can go grab coffee sometime.
I will be. Let's do it.
All right.
Great. Thanks a lot.